number 1A, Nikki Shaner. -8, comma 2. Which quadrant or which axis does that point lie? The second quadrant? I agree with you. One thing that you can use is the polarity, whether it's positive or negative, of both the x and the y. -x, positive y, that is to the left and above the origin. Okay? So it goes 1, 2, 3, 4. -8, comma 2 is someplace there. So this is quadrant 2. Allie. Pi, comma -6, I agree. Pi is just a number. It's a symbol that we use. The ancient Greeks did not use this for the ratio of a circle's circumference to its diameter. Europeans started using it like over 1,000 years later. But what matters is that you know that it's just a positive number. So positive, negative, it's going to be here, quadrant 4. Good. And Val, 0, comma 2. There's your answer. This is not in any quadrant. It is on an axis, in particular the y-axis. Or if you want to be more specific, the positive y-axis. Okay, somewhere like here. Any questions on 1? Great. Number 2, the distance formula. So a lot of times we want to know how far apart two things are. For example, if we're trying to get from one place to another, or if we want an object to go from one place to another. We have the distance formula. So first I'll show you how easy it is to come up with the distance formula. You might know something called the Pythagorean theorem. Now, this relationship was known many years before Pythagoras lived. In fact, the first proof that we're aware of comes from 1000 BC in China. But here in this country, we refer to this relationship as the Pythagorean theorem. It's just a name. Don't take it too seriously. Can somebody tell me this relationship? Yes. Very good. One of the most widely used mathematical relationships that's out there. And Brett, what is this referring to?
Inside of a triangle.
What kind of triangle? A right triangle. Very good. And what's special about C?
It's the hypotenuse.
It's the hypotenuse, which is the
The longest side.
longest side.
It's across from the right angle.
Excellent. This only applies for a right triangle. And it is the relationship between the side lengths and a right triangle. One thing that's cool about mathematics is its constancy. Like I said, this relationship was discovered in 1000 BC, or at least that's the earliest evidence that we have. It still applies. I expect it to apply 1,000 years from now. I don't expect right triangles to behave any differently than they do today. So, the A and B can be either of these sides that aren't the longest. It's just that C has to be the hypotenuse, aka the longest side. Alright, so watch how you can use the Pythagorean theorem to get to the distance formula. You can think of the distance formula as being the Pythagorean theorem written for the Cartesian coordinate plane. So, we want to find the distance between 2 points. I'll call them x1, y1, and x2, y2. Okay, we want to find this distance here. Well, There's a lot of problems that can be solved by creating a right triangle. Like drawing one, even if there isn't one there to begin with. Which is cool. You'll find when working with triangles that right triangles are your friends. They're very helpful and they're easy to work with. Okay, now I said we're going to connect the Pythagorean theorem, this relationship, with what's going on here. So we'll do this in a stepwise fashion. This point here, shout this out, what is its x-coordinate? x2, very good. What is its y-coordinate? y1. Good. You and Jay, are you okay? I'm required to check in on the health and well-being of my students from time to time. Okay, we're going to use this information to find this distance, combined with the Pythagorean theorem. Let's figure out how many units is this. 5? Is that what you said?
Yeah.
There's no way of knowing numerically how many units it is. No. How long is this side? Nice. This is x2 minus x1 units long. A lot of people stop at algebra because they can't deal with the abstraction. This is an example of an abstraction. Instead of having concrete, actual numbers here, you're thinking about it in a more general sense. Something that can stand for a number. And if you can get it, it's awesome because there's so many things that you can do with that ability to think that way. If you don't understand why it's this, well, try some numbers. Let's say that x2 is 10, and let's say that x1 is 3. How many units is it from here to here? Just shout it out. 7, which can be obtained from 10 minus 3. Okay. This side here, shout it out. How long is it?
y2 minus y1.
Excellent. y2 minus y1. Okay? Now watch the magic. Pythagorean theorem states that this side squared plus this side squared is equivalent to this side squared. Okay? x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared, is equal to, you tell me the last part, d squared. That's just the Pythagorean theorem. Take a look at the distance formula, and take a look at this. What's the only difference? Yes, instead of d squared, it's d. So we're going to square root. We don't care about the negative root because, in general, we don't have negative distance. So then that square will go away. Those have to stay because you have a plus sign here, or it could be a minus sign. You have two terms that are there, so you can't just eradicate those squares. All right, so behold the distance formula. It's the difference in the x-coordinates squared plus the difference in the y-coordinates squared, and then the square root of that sum. Otherwise, it will be d squared. Okay? When I can, I like to show you where things are coming from. And that was an example of that. The whole point of coming up with a formula, or one of the main points, is to be able to use it. So now that we've derived it, let's put it to work. I want to find the distance between these 2 points. Before the distance formula was derived, how do you think you would do it? Or how do you think one would do it? Count. Or use a ruler. Yep. But we can be more precise about it and not require any physical item to do it with. This is easy. You're simply plugging in. You can make this x2 or this x2, but what matters is that if you're going to call this x2, then this must be y2. So the subscripts have to remain consistent within an ordered pair. So I'll just use x2, y2, x1, y1. Then you're just plugging into the formula. -3 minus 2, that quantity squared, plus -4 minus -1, that quantity squared. Shout it out. What's -3 minus 2? -5. And what's -4 minus -1? Very good. -3, because it's -4 plus 1. -5 times itself is 25. -3 times itself is 9. 25 and 9 is 34. Can the square root of 34 be simplified? No, there is no perfect square factor other than 1 in 34. I asked for both an answer in radical form and as a decimal approximation. Fortunately, we have these devices that can do this for us. Square root of 34 is about 5.8. What are the units? Unknown. Okay, so instead of getting out the ruler and finding out how far apart these 2 points are, we know with certainty that they'll be root 34 or about 5.8 units apart. Any questions on 2A? Okay, I'll just ask a random person. Amber, can you guide me through 2B?
Yeah. So first you have to make the radical, or d equals the radical.
D equals square root.
Yeah. And then you would do -1 plus 5 squared.
-1 plus 5 all squared.
And then plus -1 minus 2.
Negative.
Squared.
-1 minus 2.
Yeah.
Yep. So let's just make sure that we're doing this right. This minus this, and then this minus this. You just have to have the order consistent. Very good. Continue.
Okay, so then that's 4 squared plus -3 squared, which is 9. So 16 plus 9 under the radical. And then that's 25 squared.
Square root of 25.
Yeah,
I think,
sorry, yeah. Which equals 5.
Good. So these 2 points are exactly 5 units apart. Could be centimeters, kilometers, miles, whatever. Any questions on 2B? All right, a more advanced problem. We know the distance in number 3. We do not know the x-coordinate of one of the points. Well, we can find it. I'll go to a volunteer for this one. Maybe somebody else. But thank you. Okay, Amber.
Okay. Alright, so first, because the distance was 5, I, instead of like setting d equal to the radical, I set 5 equal to the radical.
Mm-hmm.
So then I just like plugged it in the same way you would.
Yeah.
So it was then x minus 2 squared plus 7 minus 3 squared. Yeah.
Good.
And I did that.
So we're just plugging what we know into the distance formula.
Okay. So then I had to FOIL x minus 2.
It's not necessary.
Oh. Okay. Well,
What's
that's what I did.
yeah, and that's fine. It's a legal maneuver, but let me show you a more efficient way.
Okay.
What's another thing that you could do? We try to avoid
Square
expanding
both
binomial. Yes.
sides, and then there would be 25, and then like x minus 2 squared plus 7x
Yeah.
squared.
Okay, so let's get rid of that square root by squaring both sides. So 25 equals, and then just remove the radical. And we might as well simplify this to be 4. Okay. Yes, sir.
So it doesn't matter what order you write it down in, because you wrote x minus 2, even though the way it looks like in the question is, I guess, x is x1 and 2 is x2, doesn't really matter.
It doesn't matter. You just have to have some degree of consistency. So if you did x minus 2 the first time, actually, now that I think about it, it doesn't matter because you're squaring.
So if I'm doing this equal from me to be x1 minus x2 plus y1 minus y2, that's how I worded it.
It doesn't matter. What matters is that you are taking the difference between the x coordinate somewhere and somehow.
Oh, so it won't be this negative version, it won't be positive. Exactly.
Exactly. Because you're squaring it, it's a non-issue. So I'm glad you brought that up because that allowed me to correct my previous statement. Okay, Amber, please continue.
Wait, but don't you have to FOIL the x minus 2 now anyway?
It's not necessary. What could you do with the 4 squared?
Make it 16.
Yep. And what do you think you could do next?
I don't know, I would FOIL.
You can FOIL, but it's not
Oh, no,
necessary.
No. Subtract the 16 to the
Subtract
other
16,
side.
very good.
So then you can just square both sides.
So 9
9.
equals the quantity x minus 2 squared. And then what?
And you square root both sides.
Square root
so
both sides.
3
Just keep in
equals
mind that it could be the
minus
positive or negative root. So we are going to get 2 answers. So positive or negative 3 equals x minus 2.
2.
And then what should we do?
Add the 2, so
Add 2.
plus or minus 5 equals x.
2, no. It's 2 plus or minus 3, which is different than plus or minus 5. And since these are rational numbers, we can come up with the exact and not write it as a plus or minus version. So 2 plus 3,
5.
yep, 2 minus 3,
Negative 1.
negative 1. Okay, so either negative 1 or 5. Do whatever you can to understand the problem from multiple angles. So for example, you can understand this problem graphically. Sketch it out. You've got a point at 2, 3, and a point at something, 7. 4, 5, 6, 7. That means that point is somewhere on this horizontal line, because we know it has a y-coordinate of 7. Okay? Well, what we found was that if the x-coordinate is negative 1 here, then the distance is 5. And if the x-coordinate is 5, oh, excuse me, negative 1 is here. That makes more sense. I did positive 1. And then at 5. Okay, in both cases the distance is 5. Okay. Any questions on 3?